Okay, we are looking at the next section here talking about rotations. This is not a mistake. You are looking at GeoGebra. What I have here is what's called a polar graph. This right here going up and down is your y-axis. This would be your x-axis. But what these values here going around in the circle will allow us to do is take a look at rotations on the coordinate plane that would deal with like 30 degrees, 60 degrees, into 90 degrees. The ones that we'll take a look at in this section will be 90, 180, and 270. And my hope is to use GeoGebra to notice some patterns so that when we do our 90, 180, and 270 on the coordinate plane, we can see where those rules come from. Ultimately, I get that many of you will end up memorizing the rules, applying them appropriately from that, but hopefully we can at least see where that's developed out of. So I have a point A, and it is 6.48, comma 3.63. Very random point. All of our rotations will be about the origin. That's why I have point B established. So the first thing I'm going to do here is rotate around a point. So I'm taking A, I'm rotating it about the origin, and we're going to do a 90-degree rotation. Here's our new point over here from quadrant 1 to quadrant 2. That would make sense. Whatever was our horizontal distance is now our vertical distance. Whatever was our vertical distance is now our horizontal distance. So take a look at the values. 6.48, comma 3.63 has now turned into negative 3.63. And our x value of 6.48 now shows up as our y value. So really what's happened between these two is if you take the opposite of the y value, that's become our new x. You take the x value, put it as our y value, there's a new y value. That is how you're going to rotate an object 90 degrees. So if you take a look at the following here, rules for rotations, given the original point A comma B, when you do a 90-degree rotation, A comma B will turn into negative B. So take the opposite of the y value, make that x. Take the x value, make it the y value. Going back here, we're going to do another rotation. We're going to take A, rotate it about B, and this time we're going to do a 180-degree rotation. This one I think many of you would have guessed, as it shows up exactly opposite of where it was originally located. So the original point at 6.48, comma 3.63 shows up at negative 6.48, negative 3.63. You may have heard that reference. Somebody pulls a 180. Perhaps somebody's going down the wrong path, drug usage, something like that. They turn their lives around. They say, boy, this person has really turned to 180. They're now going in the opposite direction. As you can see here, x comma y now becomes negative x comma negative y. So looking at our chart here, for a 180-degree rotation, any point A comma B, its new location after that 180-degree rotation would be negative A, negative B. So whatever the original x value was, make it opposite. Whatever the original y value was, make it opposite as well. Final rotation that we'll do here today is to take your original point, rotate it around the origin, and this time we'll take a look at a 270-degree rotation. So as we rotate that, take a look at the original position. The original position was 6.48, comma 3.63 here in quadrant 1. Now, as we've went 90 degrees, 180, and 270, we've come to quadrant 4. In quadrant 4, this 270-degree rotation, notice how the original y value becomes the x value. The original x value done the opposite becomes your y value. So this value is 3.63, comma, negative 6.48. And to look at our rules here, we see that for a 270-degree rotation, A comma B turns into whatever was your original y value becomes your x. Whatever was your original x, take the opposite, and that becomes your y value. As you look at these, you will notice a pattern. Each 90-degree rotation plays out the same. AB, if you take the opposite of y, make that x, take x and turn it into y, there's 90 degrees. Now, if I go from 90 to 180, take the opposite of y, that's negative a, take x and make it y, there's 180. Now, if I go from 180 to 270, take the opposite of y, that's b, take x as is to your y, and you get b comma negative a. Just to take that one step further, 360 gets you right back where you started. take the opposite of y and make it x. That's A. Take x and make it y, and that's why you would arrive at your original position. So if I were to take A, rotate it around B, and this time do a 360-degree rotation, that's why we end up in the exact same place that we started. Now here's what it's going to look like played out with an actual object. Take this object for granted. Our original points, -5, 3, -7, -2, -2, 1, this triangle right here, a 90-degree rotation. Notice y becomes, opposite of y becomes x becomes y. Opposite of y becomes x becomes y. Opposite of y becomes x becomes y. And when we plot it, it should only be moving one quadrant. Notice how A is in quadrant 2. When I rotate it 90 degrees, it ends up in quadrant 3. C is already in quadrant 3. Notice how when I rotate it, it ends up quadrant 4. Notice also how the object looks exactly the same. For a 180-degree rotation, notice that each value, x comma y, or in this case, -5, -3, we see the same values just opposite. -5, 3 becomes 5, -3. -7, -2 becomes 7, comma 2. -2, -1 becomes 2, 1. We've applied those rules. Whatever AB is turns into -A, -B. Also notice 180 degrees would indicate two quadrants. So here, this C has went from quadrant 3 to 4 to finally 1. A has went from quadrant 2 to 3 to 4. Each one is moving two quadrants. Finally, the final rotation we'll take a look at here is a 270-degree rotation as I go ahead and connect this final side together. And what you're looking at here is you have your original points, and now notice how the y value becomes the x value. Take the opposite of the x value, there's your new y value. Take the y value, make it the x value. Take the opposite of your x value, make it y. Take your y value, make it the x. Do the opposite of the x value, and there's your y. And notice how we're moving three quadrants here. That's what 270 degrees is. A moves 1, 2, 3 quadrants from quadrant 2 all the way to quadrant 1. Another 90-degree rotation will get us right back where we started. So these rules here are what many of you will use throughout, but I wanted to use GeoGebra to kind of prove that as you move that around counterclockwise 90 degrees as you're moving a quadrant, that these are the things that are going to happen with your original x and y values.